Hi, in this section we will use node analysis to find the node voltages. First of all, we will show you steps to find out the node voltages. Then we will start to give example, and also we're going to give some useful link to use the TI calculator to find the two equation, two unknowns, or multiple equation, multiple unknowns answer. Then we're going to show also Cramer rules to solve two equation, two unknowns. Then we will give some more example. Okay, here the steps to find the node voltages. Number one, select a node as a reference node, 0, first. So we have one node as reference. The rest of the nodes, or remaining of the nodes, we're gonna call them, assign them 1, 2, 3, which is the voltage will be those nodes V1, V2, V3, all the way Vn minus 1. So the voltages are reference to the respect to the reference. That's why when you're gonna have respect to the reference voltages. After that one, assigning the nodes, we will write the KCL for each of the non-reference nodes. Then we will use Ohm laws to express those branch current in terms of node voltages. Then we're gonna solve those simultaneous equation. So it depends on how many unknowns we have it. That's why we have many unknown equation, many equation 2 also. In this example here, simple way, the reference node will be here as 0. Then we have one node here as 1. We have another node as 2 here. Okay, so this voltage will be V1 reference to node 0, V2 reference to also node 0, basically. Okay, so we don't have any more nodes, so we have V1 and V2. So to find the V1 and V2, we need to write two equations. So we're gonna apply KCL for those nodes. So first node 1, if you look at here, capital I2 going in, capital I1, I'm sorry, capital I1 going in, okay, will be equal capital I2, which is this one here, we have it, plus lowercase I1 plus I2 here, because this is going out, this is going out, you can see here. If you modify this one, we can leave lowercase I1 and I2 on the one side. We can put the capitals on the other side because those are known current sources. So let's write the node equation KCL for node 2 in this case here. In this case, capital I2 and lowercase I2 entering the node, that's why we have this one's plus right there, will be equal lowercase I3 because exiting from the nodes. So if you modify this one, we will have negative I2 plus I3 will be equal capital I2. So this is our equation 1, this is our equation 2 here. When we look at here, we don't know lowercase I1, I2, and I3, but we're gonna write those currents in terms of node voltages. So next slide here, it shows that how we can apply Ohm laws to write those current as voltage nodes. So basically, the current flows any elements from higher potential to lower potential. So that's why current will be equal V higher minus V lower divided by R. So if I look at here, if I want to find out I1 will be equal V1 minus 0 divided by R1. Is 0 is gone, so we're gonna have I1 will be equal V1 over R1. Same thing, if we write the I2, which is on the middle, will be V1 minus V2 divided by R2. That's what we have right there too also. When I look at the I3 on the right side resistance, that will be V2 minus 0 divided by R3. That's why equal V2 divided by R3. So 1, 2, and this 3 current, we're gonna apply there our KCL equation. We're gonna substitute our KCL equation. If you remember, first one was I1 plus I2. So I1 is V1 over R1 plus I2 is V1 minus V2 divided by R2 will be equal capital I1 minus I2. Second equation was, if you go back again one more time here, negative I2 plus I3 equal capital I2. So negative I2 means negative V1 minus V2 over R2 plus I3 is here, which is V2 over R3 will be equal capital I2. So we can combine them as under V1 and V2 first equation. Second equation, same thing, we can combine under V1 and V2. So this way, if we know the resistance value, we have two equations and two unknowns. Those unknowns are not voltages, V1 and V2. We can find them. There is multiple ways to find those two equations, two unknowns. Students using TI calculator find them easily. I use MATLAB. Easily I can find out. I can show you step by step how you can find two also. But if you have a TI calculator, there are multiple links to how you solve those multiple equation, multiple solutions easily. I also give you ORCAD website too if you're gonna download the PCPies. Here, actually, one of the manual solving is using the Cramer rules to solve T equation to unknowns. Because of the 1 over R1, we convert them to G1, G2, G3, and G4. V1 and V2 unknown. I1 and I2 are known. So first we can find the determinant of the matrix. What is determinant of matrix? Means G1 times G2 minus G3 times G2. That's why you have it. This should exist first. If it's not exist, you cannot find the values. Okay, if this exit, if you're gonna find the V1, we just take this same matrix here, replace the first column with the output, the right side of the equation, I1 and I2, then divide, find the deterministic of that matrix divided by delta. So in this case, I1 times G4, which is right there, minus I2 times G2 will be here, divided by delta. If you're gonna find V2, in that case, from the equation, we're gonna replace this second column with the right side of the equation. That's why you're gonna have G1 times I2 minus G3 times I1 divided by delta. You can find this way easily. For 3 by 3, so if you have 3 equation, 3 unknowns, I can give you a link. I have it another website. It can show you how you step by step them too also. But mainly you're gonna use the calculator to find the values. I don't want you guys to spend too much time manually find those values. Let me give one example here. Okay, in this equation it says find out V1, V2, I1, I2, and I3. We want to use again node equations. Okay, so we select this one as our reference, which is node 0 here. We have left right there, one is node 1 right there, which is we call V1. The other node is here 2, we call V2. So step 1 is done. Step 2, we're gonna write KCL for each node. At node 1, 3 milliampere is going in here, will be equal I1 plus I2. because those are out here. That's why first equation is I1 plus I2 will be equal 3 milliampere. Okay, so at node 2, I look at here, I2 is going in, I3 is out, and also 12 milliampere is out. So that's why it will be I2 minus I3 will be equal 12. So the next step, we need to write the current using Ohm laws. We're going to write the current as reference, not voltages. So I look at the I1 here. I1 is right there, will be equal V1 minus 0 divided by 1K. I2 will be equal V1 minus V2 divided by 2K. I3 will be equal V2 minus 0 divided by 4K. So we need to substitute. So we have two equations, KCL equation here. We need to substitute this A, B, and C to current KCL equations. So I1 is V1 over 1K plus I2 is V1 minus V2 divided by 2K will be equal 3 milliampere. Then next one is I2. I2 is V1 minus V2 divided by 2K minus I3. I3 is equal V2 divided by 4K, which will be equal 12 milliampere. So we have two equations again, two here. But if you look at these equations, those are a function of V1 and V2. So we have two equations, two unknowns. We need to simplify them or combine them under V1 and V2 separate, so we can write our matrix, we can solve them. So here we combine them under V1 and V2 first equation. We combine second equation V1 and V2 here. If you put the reference values, the voltage, if you simplify this one, it's coming here this way here. So we have the matrix equation. So we can find the deterministic of this matrix. Then we can find V1 and V2. Here is another example. In this example, first we select this one as reference. Our reference. We have node 1 here, V1, node 2 here, V2, node 3 here, V3. So we need to write three equations. Okay. So first one is here, 3 ampere going in, I1 and Ix going out. That's why I1 plus I2 will be equal to 3 milliampere. That's the first equation for node 1. For node 2, Ix is going in, I3 and I2 out. So that's why Ix is in plus, negative I2 going out, negative I3 going out will be equal 0. This is equation number 2 here. The next one here, the node 3 here. I know I1 is going in plus, I2 is going in plus, minus 2Ix will be equal 0. So this is our next equation. Next step, write the current as a function of not voltages. We'll look at the I1. I1 is right here, which is I1 will be given V1 minus V3 divided by 4 ohms. It's given like this here. Ix is right there over 2 ohms. That one will be V1 minus V2 divided by 2 ohms. It's right there. Next one is I3 is right there going to reference 4 ohms resistor again. This case will be V2 minus I2, I'm sorry, is right there. I2 is this one here. V2 minus V3 divided by 8 ohms. I3 is right there, will be V2 minus 0 divided by 4 ohms. So we're gonna substitute those currents in each equation here. When we substitute them, and when we substitute each one here, so our equation will be a function of v1, v2, and v3, and we have three equations. We can simplify those equations as function of v1 and v3. Then we can write the matrix form. Then we can find v1, v2, and v3 directly. I show you code how you can find with the MATLAB easily too also. If you have any question, please prepare and bring it to class. We can try to cover them. Thanks.